Welcome dear student and Jai Swaminarayan. In the previous video, we will discuss about the Dobrener's classification of the element and Newland's classification of the elements. Dobrener's law of triad and Newland's law of octave and their limitation of the classification. So at the time of the Dobrener, there were only 30 elements are known to us. At the time of the Newland, there were 56 elements known to us. After that, Mendeleev are also try to classify the elements with their chemical property, with their physical property, with their atomic mass. So at the time of the Mendeleev, right, there are 63 elements are known to us, right? So today in this video, we will discuss the Mendeleev's periodic table, how the Mendeleev classified the elements according to their atomic mass, according to their physical property, according to their chemical property, and what are the achievements of the Mendeleev's periodic table, what are the limitations of the Mendeleev's periodic table. So dear student, let us start with the Mendeleev's periodic table. So Mendeleev started his work. At that time, the 63 elements were known to us, right? 63 elements were known to us. He examined the relation between the atomic mass of the elements with their physical and the chemical property, right? So Mendeleev are classified the elements according to the atomic mass of the element and compare the atomic mass of the element with the physical property and the chemical properties of the element. So Mendeleev classifies that the elements in the 8 group in the vertical column is known as the group. So Mendeleev classified that the all the elements are classified in the 8 group: group 1, group 2, group 3, group 4, group 5, group 6, group 7 and group 8, right? And horizontal rows are called the periods, right? So there are 6 periods in the Mendeleev's classified. Also in the one group, right, there are two subgroups, subgroup A and subgroup B. So at the time of the Mendeleev, there are 63 elements were known to us, right? Hydrogen, lithium, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And the atomic mass of the element is given to you here. The atomic mass of the hydrogen is a 1.008, atomic mass of the lithium 6.939, atomic mass of the beryllium 9.012, right? So you have to remember this element table up to the 30 elements, right? So Mendeleev classified the periodic table according to their oxide and their hydrides, right? In the first group, oxide and hydride is there. In the second group, oxide and hydride. In the third group, 3 hydrogen and the 3 oxygen are present. In the fourth group, 4 hydrogen and 2 oxygen are present. So according to their oxide and the hydride, the Mendeleev classified their elements, right? So in the period, first period, there is only one element is there, hydrogen. In the second period, there are 7 elements are present: lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine in the increasing order of atomic mass. So as we move from left to right in a group, right, as the group is increased, the atomic mass of the element is increases, and as we move in a one group in a different period, as the period is increased, the atomic mass is increased. So Mendeleev classifies the elements according to the atomic mass with the physical properties and the chemical properties. Mendeleev classifies the properties of the oxide and the hydride, right? So in the one period, two sub-periods are there. In the period 4, 5 and 6, there are two different series sub-periods are there. So you have to remember the classification of the Mendeleev's periodic table, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, right? So up to these three videos you have to remember the atomic mass of all the elements, right? Then potassium, calcium, cesium, lithium, right? That all the elements. So in this group 8, right? There are three subgroups are there, right? Three columns are there. Fe, CO and nickel. The mass of the Fe, CO and nickel are put in the increasing order. So in the group 8, right, there are three columns are there, subgroup. In the period 4, 5, 6, there are two sub periods are there, and the Mendeleev classify these different elements according to their oxide and the hydride property, right? So Mendeleev classify the element in the increasing order of their atomic mass and similarities in their physical and chemical properties. The formula of the oxide and hydrides formed by the element was also the basic fundamental of the classification of the element. So the basic of the Mendeleev's periodic table is a oxide and hydride formed by the elements. So oxide and hydride formed by the elements are in a one group. So basic thing in the Mendeleev's periodic table is the oxide and hydride formed by the elements. So Mendeleev's periodic table has the 6 horizontal rows, that is called the period. So in the Mendeleev's periodic table there are 6 horizontal rows, that is called the periods, right? And 8 vertical rows called the groups. So 8 vertical rows, that is called the groups, right? So in the Mendeleev's periodic table there are 6 periods and the 8 groups. The group 1 to 7 had a 2 subgroup called A subgroup and B subgroup. So in the first 7 column, in the first 7 group there are 2 subgroup. First one is the for the oxide and second one is the for the hydride, right? Or two subgroup, we can say that the subgroup A and subgroup B. So first 7 P group has a two subgroup A and subgroup B. One is for the oxide and one is for the hydride, right? So the Mendeleev periodic table has the 6 horizontal row. They is called the periods, 8 vertical rows called the groups. Group number 1 to 7 is divided into the two groups, subgroup A and subgroup B. One is for the oxide and one is for the hydride. Group 8 has a 3 rows of the element. So in the group 8, 3 columns, sub-columns of the elements are there, right? So element having a similar properties were placed in the same group. The element which has a similar property, similar hydrides are there, similar oxides are there, similar physical properties are there, similar chemical properties are there. These are placed in the same group. There are some space left vacant in the table to accommodate the elements to be discovered in the future. So in the Mendeleev's periodic table, there are some space left vacant to for the future element, that is the elements that to be discovered in the future, right? So understand, dear student, Mendeleev's periodic table. Now what are the achievements of the Mendeleev's periodic table? In the Mendeleev's periodic table, the elements were classified on the more fundamental basis of their atomic mass and the oxide and hydride property, on their chemical properties and physical properties, right? So first achievement is the elements in the Mendeleev periodic table were classified on the more fundamental basis as the previous classification, according to their atomic mass and according to their physical properties, chemical properties such as the oxide property, hydride property, like this. Second achievement is that some space were left vacant to accommodate the elements to be discovered in the future, right? The elements which are discovered, which will discover later, there will be some space vacant in the Mendeleev's periodic table, right? Third achievement is it could predict the property of the elements which help in the discovery of the new element. So here in the Mendeleev's periodic table, the elements which are in a which have a same property, right, are placed in a one group, and that could help us to discover the new elements. And next achievement is that the inert gas elements discovered later could be placed in the separate group without disturbing the table. So some inert gas that will be discovered later we can place in a separate group without disturbing this table, right? So these were the achievements of the Mendeleev's periodic table. Now, let us see the limitation of the Mendeleev's classification. So, what are the limitations of the Mendeleev's classification? The some elements are not arranged in the increasing order of their atomic mass. As the Mendeleev classified the elements according to their oxide and hydride property, there are some elements are there that are not arranged in the increasing order of the atomic mass. For example, here the cobalt is placed before the nickel, titanium is placed before the iodine, that is right. So here let us see this group. In this group, the cobalt CO has a atomic mass 58.93 is placed before the nickel, as the atomic mass of the cobalt is more than the atomic mass of the nickels, right? So this one is the first limitation of the Mendeleev's periodic table. Some elements are not arranged in the increasing order of their atomic mass. For example, here see this titanium has an atomic mass 127.60 and iodine has an atomic mass 126.90. So as per the oxide and hydride, right, as per the increasing order of atomic mass, the iodine is could be placed before the titanium, but as per the oxide and hydride property, the titanium is in the group 6 and iodine is in the group 7. So first limitation of the Mendeleev's periodic table is that some elements are not arranged in the increasing order of their atomic mass, right? Cobalt is placed before nickel, while the atomic mass of the cobalt is more than the atomic mass of the nickel. Second, the position of the hydrogen is not clear because it shows the properties similar to the metal as well as the non-metal. So here the position of the hydrogen in the hydride of the elements, the position of the hydrogen is not clear because the hydrogen shows the property of the metal as well as the non-metal. So the position of the hydrogen is not clear in the Mendeleev's classification of the element. And third, the position of the isotopes of the element is not clear, right? So where the isotopes of the element is placed is not clear in the Mendeleev's period. What do you mean by the isotopes? Isotopes means the elements which have a same atomic mass, same or different, same atomic number and the different atomic mass which has a similar properties. So what are the position of the isotopes of the element is not clear in the Mendeleev's periodic table. So dear student, understand what are the limitation of the Mendeleev's periodic table. What is how the Mendeleev's periodic table, Mendeleev classifies the different elements. The Mendeleev classifies the different elements on according to the increasing order of their atomic mass. And the fundamental basis of the classification is the oxide and the hydride formed by the elements. In the Mendeleev periodic table, 6 horizontal rows that called the periods, 8 vertical rows are called the groups. In the group 1 to 7, 2 subgroups are there, one for oxide and one for hydride, right? And some space is left vacant in the table to accommodate the element to be discovered later, right? Achievements of the Mendeleev's periodic table: the more fundamental basics of their atomic mass according to the chemical properties and the physical properties, right? Oxide and the hydride properties of the element. So the classification are based on the more fundamental basis, right? Some space are left vacant to accommodate the elements to be discovered future, right? Third one is it could predict the properties of the element. The properties, the physical properties and chemical properties. The properties of the element. The similar properties of the element were placed in the similar group. So we can predict the discovery of the new element. The inert gas element discovered later could be placed in the separate group without disturbing the table. And then what are the limitations? Some elements in the Mendeleev periodic table, some elements are not arranged in the increasing order of their atomic mass. The position of the hydrogen is not clear. The position of the isotopes of the element is not clear, right? So I hope that you understand this Mendeleev's periodic table, the achievements of the Mendeleev periodic table, and the limitation of the Mendeleev's classification. So next is the modern periodic table, that is classify the elements according to the Henry Moseley, right? That we will discuss in the next video.